All right. Hey, everybody. It is the 25th of March, 2024, and we are here for some Cardano Go live coding. We meet on Mondays at 1300 UTC. So if you're catching this on YouTube, be sure to join us, and you can find all the details at gimballabs.com/calendar. So what we've been doing, I'm going to share screen right away, is we've met twice so far, and we've had a little bit of time to start thinking about the structure of some CLI written in Go. And because we're building on Andamio right now, we're using this as an example. But I think a lot of what we're doing here is pretty general. We're thinking, how can we write certain kinds of data, like metadata for NFTs or for something else, like datum for different transactions that involve validator interactions. We have queries, and we did a silly example the first session where we're able to query the tip of the blockchain, but under the hood, there's a lot of great stuff going on. And last week, Mix showed us how to build a transaction. It was a simple one to start. But what we now have are these islands where we can start to run more interesting experiments. And that's really what I wanted to start today, is just thinking about what we might want to build here from two perspectives. One, what's useful for this Andamio use case, but two, and maybe more importantly for now, what are some things we just want to play around with because they're really helpful concepts for anybody who wants to use the different Cardano Go libraries. So really, when you build software, obviously you're supposed to be solving a problem, not just looking for places to use the tools. But we're absolutely going to break that rule, right? We're going to look for spots to say, hey, here would be a good example of the use of this tool just for its own sake, so we can start to play with that. And this is where, Chris, I wanted to start by asking you. You've already been thinking along these lines with the Ouroboros starter kit and the different little microservices that stand alone that people can just play around with to get to know the tool. So what's your thinking there? And what are some other things you want people to have a chance to play around with?
Yeah, that's a good question. So, I mean, I'm wondering and kind of looking at this, and as I'm reading this, I'm looking at kind of what we've written here, and I'm wondering how much it matches up with UTXO RPC, right? Because it doesn't necessarily have like write, for example. That's an interesting thing that could that is kind of unique, right, to the Andamio CLI. But the query part, if you look at UTXO RPC, it's broken up into like build, sync, submit, and watch, right? And and like you've already sort of started down this to where right here for us kind of already matches up with build,
Mm-hmm. Mm-hmm.
right? So, you've already kind of got that going. Sync, we don't have it all, but that's okay. But that's chain sync. And I do believe Mix was showing some examples of that.
Mm-hmm. Mm-hmm.
Um, but so that's one that could be added essentially down here into ours is, like chain sync. Especially if you do chain sync with any kind of filtering or anything like that, right? So that you can show that kind of a path. Submit is your transaction, right? And what's interesting is query also falls under build,
Mm-hmm.
uh, specifically. Like in the case of UTXO RPC, is query and write both kind of go together to build a transaction, right?
Mm-hmm.
So watch is also like we don't have anything for watch. And watch is just a case of watching for transactions. So you can
Right.
create, specific filters or whatever and watch for those things. So it's related to sync, but different, right?
Right.
Because
Right.
sync is for getting blocks, like you can get transaction data out of it, but it's for getting blocks, right? And watch is for watching for transactions. It's specifically.
Right. And then so Snack would be an example of an app that you built that does sync and watch.
Um, yes, but it's not using this. But
It's
yes,
not using UTXO RPC.
correct. Not yet.
Right.
Yeah,
Right.
not yet.
Okay.
Um, yeah. So there's a Go SDK for it already.
Beautiful.
And yeah, so all of the client side stuff, and it's auto generated. So the nice thing is UTXO RPC was something that both TX Pipe and Blink Labs put in proposals in Fund 11 for, and both of us got funded. So they're working on the Rust side of UTXO RPC. We're doing the Go side of UTXO RPC. And there's actually already other people in the ecosystem that are building other ones. We have a Haskell, we have JavaScript, we have a couple others that are being done. We've got C sharp, right? Actually, all of .NET. So C sharp and I guess F sharp also works, according to Clark. So yeah, I mean, like we've got a lot of it, and it's all code generated. So the UTXO RPC spec is written out, and then we generate gRPC code. So we've written our own gRPC protocol essentially, and all of these different teams and people are adopting the exact same protocol. And it's designed by the community, right? It's like designed by us builders that have been building infrastructure and building the low level stuff, right? And so we're trying to kind of design it for usability from the developer standpoint more so than directly being like how nodes would communicate with each other, right? We're creating an actual RPC layer for development for software to run on top of, versus like this is specifically how nodes will communicate with each other.
Yes. Yeah.
Now, there's absolutely no reason why the UTXO RPC chain sync couldn't be used or anything like that, right? For node communication, but it doesn't need to. Is the point?
Well, the
Uh,
closer you can go to the source, yeah. Just if you're natively building interactions with the chain, more is possible.
right, right. So that's definitely we're working on. Dolos is TX Pipe's Rust implementation of of a node built on UTXO RPC currently.
Yeah.
We're building Cardano Node API, which we're actually building it as a sidecar to the node instead of a fully standalone node. And so it's like we're taking two different approaches to the same problem, and of course theirs is in Rust and ours is in Go. The idea is theirs is designed to be a data node. Ours is designed to give you the same API in a infrastructure where you already have like one or more Cardano nodes, right? Like you're already running it for whatever reason because you need it,
Right.
but you want to run UTXO RPC API and be compatible with Dolos and be compatible with anything that's built out of the .NET, the
Exactly.
Haskell or the whatever.
Exactly.
Um, and the nice thing is with that, all of the code generated that we build into the SDKs is works across all of these products. Right. So if you're writing in Haskell, you have a Dolos client, you have a Cardano Node API client already. If
Right.
you are writing in JavaScript or TypeScript, there's already a client. If you're writing in Rust, if you're writing in Go, right? I know that they've got a Python one. So like we're trying to work on getting all of the languages represented and getting like the right teams or at least a developer from essentially the right language owning that part of the code. But then it's all auto generated. So there's auto-generated code that gets published, and that's the SDKs for everything. In the case of Go, we actually, because the way that Go publishing works, it uses GitHub or Git, right?
Right. Right.
So our publishing publishes into a Git repo directly, and then we consume that Git repo as a dependency in the Go SDK.
Yeah.
So the SDK is ridiculously tiny. In fact, it's something that you could go look at and you could easily cover the entire code of the SDK in well under an hour because it is ridiculously tiny. Like you do it in like 10 minutes. It's
Well, so
uh,
we should do that in one of these, like maybe
yeah, yeah. It's just a wrapper
yeah, 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 yeah.
around the auto-generated code that comes out of the spec. And so the spec is written, using protobuf. So there's a way to create, like the design, the shape of all of the objects and all of the specification, and then each language has a protobuf compiler that basically generates code for that language, right, from the single specification. So now we're all on the same playing field, right? Like we're all building the same objects that look the same, that act the same, on the wire, all of this sort of stuff, right? So it's very nice uh, in how everything is built for us and maintaining compatibility, right? Like as long as we're on the same version of the UTXO RPC spec, we all of these things are automatically compatible with each other.
Yes, yes, yes.
So if you're running on Demeter and running workloads and running using Dolos or something like that, you could switch to say Cardano Node API in Dandelion or whatever, right, from your app and not have to change your backend at all.
This is the
Like
thing.
that's the idea, right? Is you build using these SDKs, and it's like so now you're agnostic to the underlying, like tech choices, that sort of stuff. You're free to move between providers. Because like right now, everything is extremely specialized, right?
Right. Exactly. Exactly. Well,
Yeah,
I'm playing with the picture here because ev we know that everybody's going to have their own entry point,
right,
right? We have this background, or I want to learn to build in that, fine. And at the end of the day, wherever people come in, we eventually want them to understand this spec so that they can say, well, wow, there's this other tool over here. I used this tool as far as I could. Great. And I realized there was some other stuff I wanted to be able to do. Now I am inspired to understand this UTXO RPC spec
right,
because once I do, now I can speak in all these languages, even if it's just to communicate across a team, right? Collaborate.
right. Well, the other thing is we're also talking about the front end. So the
Yep,
front end speaks
exactly.
this spec too. So
Right,
it's a
right,
TypeScript API. There's
right,
JavaScript. So the point is you don't have to know Cardano Node API or Dolos or anything like that. You don't have to care at all. All you need to know is that you're using this UTXO RPC SDK
right.
language, and it works the same across everything, and that's the entire point, right, is being able to migrate, being able to uh you know be able to not have to necessarily worry about how your code works. UTXO RPC and gRPC in general is a binary protocol, which means all of the things are very, and it's strongly typed, it's extremely well defined, like everything is very very specific and specified. So there's that's also why you're able to generate all of the code, right? Is because every interaction is specified in every way. So there's no ambiguity between the different languages, all that sort of stuff. It makes it really nice.
So I've only done like a cursory level read about it and just haven't had time to go deeper yet. I'm so excited that this presents like an opportunity to do so. And like you said, like taking a first look at that SDK would be a chance for us to start, for me to like try to understand it, right? Make sure, okay, yeah, that all makes sense based on what I know,
Yeah.
and to have a chance to ask questions. But before even that, it really gets me thinking, what is the on-ramp to this? As I think about this, I want to figure out like what can we do from the entry level perspective of a Plutus PBL course
Right.
to set people up to understand this spec so they shoot into here saying, okay, I've got like the basic mental model I need. Now I'm ready to keep going.
Right.
Um, so yeah, I mean, is it essentially like if I can build a mental model from Cardano CLI, I am 90% of the way to understanding this spec
Oh yeah. Yeah.
right?
I mean, again, if you scroll back over to our chart that we were just talking about, right? We have this is the spec, right? Is it's build, submit, sync, and each of these have a few functions. Like
Bingo.
watch actually has one function.
Yeah, yeah,
It's watch
okay.
TX. That's it.
Yeah, yeah,
Build has a few, and they're related to querying and related to building a transaction. Submit is also extremely simple. It is just
right.
submitting a transaction. No, I mean, right. So, some of it is very easy to learn. Chain
Right.
sync has three separate functions. It has follow tip,
Yeah,
right? So basically, stay in sync. It has a history and like dump history, and then it has block fetch,
yeah,
right?
yeah.
So I mean, it makes sense that it's pretty simple. Um, again, there aren't that many endpoints in this stuff. All of the back end work, is done in the implementations. But all of the interface is completely specified, and that's the point. Is it always will work the same, right? So
That's cool. Okay, so I mentioned Sneck earlier because I did play with that a couple months ago and
yeah.
just learned the basics there. Would it be true that we want to re-implement something like Sneck built on Cardano Node API? Is
I
that
mean, yeah, you could absolutely do that.
or is that even trivial? Like it's already done for you here.
So at some point, I absolutely am going to be adding the UTXO RPC client and stuff like that to Sneck, right? And Sneck itself will be UTXO RPC compatible.
Yeah.
So it will be using these things, and then doing its filtering and that sort of stuff. And so there are some interesting parts on some of these where, like you can add some of your own filtering. So it means that we'll be moving a little bit of Sneck functionality left, so to speak, right? Because we'll have filtering already built in some cases, some specific types of filtering, that sort of stuff that's defined in the spec.
Excellent.
Yeah, so that'll help, in making, Sneck itself a little bit lighter weight. Um, because we're basically moving that to whatever the data provider is, right?
Well, and part of the reason I asked is, I mean, we're working together on this catalyst proposal, and there is a line in that proposal just for other contributors, right, to start jumping in. And so, like this as just an example of something that could be done in the future,
Yep.
what I'd like Cardano Go PBL to do is get people ready to maybe be the contributors, right? Who can make that PR
Yeah.
where they're making this integration right here. And
Right.
so think about like those endpoints. We're going to work through a course that's going to start. We're going to be ready to start developing that within the next few weeks.
Hmm.
But then the outcome of that is people who are ready to keep the ecosystem growing and working.
Right.
All right, should we take a look together at the spec and
Sure.
then Cardano and then yeah.
Well,
I'm using this term right. Cardano node API
yeah.
is
So
the Go implementation of the spec. Yeah.
it is a Go service that serves UTXO RPC. The Go implementation of the spec is the Go SDK.
Oh, got it. Okay. Okay. Okay.
Yeah, so
Service
UTXO
built
RPC
up.
has its own SDK for each language. Go is the only one that actually has like a repository that it's jammed into because, like I said, of how Go distribute software, right? In
Okay.
via Git. So when a build runs, it generates Haskell packages in node pack or npm packages. It uploads them to npm. It uploads it to Hackage. It uploads to like all of these various package managers, and then it creates and pushes to the Git repo for Go. So
Right. Right.
everything else it's just pushed directly to all the package managers. So there's not like a specific repository to go look at for the auto-generated code. Because why store the generated code in a Git repo was essentially their thought process because it's all generated.
I'm still wrapping my head around that pattern sometimes. It trips me up for a second. But yes, that's
Yeah.
exactly right. And that's beautiful.
Yeah. So anyway, yeah, we could absolutely go look at it. It's
Let's take
easy.
a look. So, and let's start just for com completeness sake, right here from the home page. How's that look?
Yeah.
So
Looks
utxorpc.org,
yep, that's it.
and we can jump into the documentation. And we want to see, let's start with the Go SDK. So this
Oh
is
yeah. The
Git
docs
repo
aren't
that you
that
were
great
talking
here.
about. That's okay. That's okay. It's enough to see, I mean, but this is what you're talking about. I mean, basically both to use the package and to learn about the package. It's
Yeah,
all,
go there.
yeah.
Yeah, I actually didn't realize that this doc site is separate, and so I'm gonna make sure that we get in here. So I do have one example under the examples, but you'll see if you look at main, if you go back to the other one, you'll
Oh,
see it's ridiculously simple here, real quick.
oh yeah, right here.
So this is the entirety of the code. Okay, so yeah. So I was like, it's not gonna take you long.
Right.
Um,
No, this part,
Yes, yes. So
right.
again, this is a really, really tiny wrapper around like the four main functions: build, sync, submit, and watch, right? From the code. And again, it's generated code, right? So we just import all of that generated code. You'll see that we create a client that has each of those clients in there. So there's a chain sync, a ledger state, a submit, a watch, right? And when we initialize the client, we create one for each one based on our URL, and that's it. That's the entirety of what this does. So there's a couple other functions we're going to add to it, like the ability to inject custom headers, that sort of stuff, that might be necessary for authentication or any of those sort of things. But otherwise this is it. It's extremely simple, and the point is you use the various methods that are documented. And so, like there's not really any particular documentation here because the documentation is generic into what the function names are and what things that you pass them. So back on the UTXO RPC page, when you're looking through the docs, you can just look at the modules. You don't have to look at like Go specifically at this
Right
point.
on, right on.
Um,
Build, submit.
Right. So if you look at the build module, and it tells you about the spec instead, right? You see what I'm saying? So like get chain tip is get chain tip. It works the same in every language. It has the exact same parameters. These are what the parameters look like in every language,
Right, right,
right? So it makes it
right.
yeah, so it's kind of nice, and this is exactly what they look like. This is the shape of every one of the objects. This
Mhm.
is where it's stored, right? Like these are what they are. They're right. Every one of the types, So again, everything is extremely defined.
And this is already working.
Yes,
Yeah,
yes.
right. That's
Uh, Yeah, Dolos is already running. They
Right.
have it running in Demeter. I mean, it's being used in a lot of places. We are writing all of this into Cardano Node API, which will be, yeah. So this is like your build module. These are the things that build has. These are the 5 endpoints that build has.
So yeah,
Right.
we just need to build examples that consume each of these.
Yeah.
Yeah. Beautiful. Beautiful, beautiful. Submit has one.
Oh, no, actually it has more than one. There we go.
Those are helpful.
Yep. And this is interesting too, like wait for.
Yep. Yeah.
And the interesting thing is where you are able to get it from is like how many confirmations do you want, all of this sort of stuff. So when you think about that from a front end standpoint, you're like,
Oh,
oh, I want to
baby.
submit, right?
Yeah. Yeah.
I want
Yeah.
to submit, and then I want to wait for it to have 3 confirmations, and then I want to do Y. You know what I mean? Like, so you're
Exactly. And it's right. And the logic, the point is nobody should have to rewrite that logic over and over again.
correct.
And we've all been doing it.
Yes.
So,
Yeah, I mean that's exactly it. Is everyone's doing it? Everyone's doing it in all these different languages.
yeah, yeah,
Every
yeah.
single provider of services has their own layouts for everything. I mean, like there's no real good standardization across our ecosystem, and we've been trying to do so. And our way of doing it was this. Right.
This,
So
right, right.
TX Pipe started this, and Santi reached out and was like, hey, do you want to own Go? I'm like, yeah, no problem.
Yeah,
And so that's where it went. And we've been collaborating on the TX Pipe Discord. There's a UTXO RPC channel over there. And, governance has basically been, consensus on Discord,
yeah,
right?
yeah.
So it's been pretty quick, and for the most part there's not a lot to discuss in the spec, right? Like unless we want to add new features or things like that, right?
Right.
Unless we want to change the shape of any of these objects, like if we want to make it so that we add a new feature that might change the shape of the request and the response, right? For submit, for example, or something like that. So that's the only real discussion. And then other than that, it's just, make sure that you've got a decent wrapper for an SDK.
Right.
And you saw how big the Go SDK is. The Rust SDK is about the same size. It's ridiculously tiny. I mean, it's just a quick wrapper around it.
And that what that wrapper does is it allows me now to have each of these things. And so now I can say chain sync dot. Oh, there's chain. Oh, that's the bottom one.
Yeah, submit
Right.
or
Chain sync dot one
fetch
of
block
these guys.
dump history follow tip. Correct.
Right.
And you use the request is the
Yeah.
follow tip request type is what you pass it as arguments,
Yeah.
right? Or whatever, and what you get back,
Yeah.
so yeah,
Yeah.
it's all pretty well specified in exactly how the different pieces work. And as I said, if you look in the SDK, there's a single example for sync,
Beautiful.
and it just uses block fetch.
Mm.
And you'll see that it's really pretty small. In fact, most of the code is setting up the HTTP client,
Right.
right?
Right.
So you can see that we have a client, your UTXO RPC client. You see we're connecting to Demeter. You pass it an HTTP client, which we already pre-constructed above.
Yeah. Yeah.
And then for the request, you see here's where the UTXO RPC stuff kind of kicks in. We got a connect new request, and connect is the library we're using to connect, right?
Mhm.
And
And that's a
the
general, this is general to any RPC that somebody builds.
connect is they it's gRPC. So they
Geo.
they have a wrapper around gRPC, and our UTXO RPC is a specific implementation of a gRPC based protocol, because gRPC is just a binary protocol over HTTP. So it doesn't have its own shape essentially, right? Like it's just a way of creating your own protocol. So you want to create your own RPC over HTTP. There's multiple methods of doing it. And one of the most common ones is JSON RPC. And that's what most people would be familiar with, where you pass a JSON payload right to some endpoint and it does a thing and returns you a response. gRPC is just binary instead of JSON, but it's essentially the same thing. It's already a pre-described shape of exactly how the data should look. Connect RPC is capable of doing both. So that's why we chose the Connect library. Is it's capable of doing whatever. Our HTTP client here, you can see we're actually configuring it as a HTTP2 transport. But we're allowing connections over HTTP. So like we configure all of that kind of stuff directly, meaning like we don't require TLS, which means it works over, like localhost, that sort of stuff without
Right.
HTTPS,
Right.
which, we just did for testing. But so then you can see that after we've created our client, right, and we've told it where to go, we create our request, right, which is we're going to do a fetch block request, and we just start with an empty one, a default one. And then we actually make the request and it gives us our response back
Mhm.
at our chain sync. And then we just print it.
Live chain sync fetch block. Love it. The local setting is also helpful for teaching, as it turns out. So I'm glad it's here. Thanks.
Yes, because gRPC by default, specifies that things are over HTTPS. And so you have to build, if you just do gRPC by default, it will expect HTTPS and it won't work without it. So I made sure to put in here, yes, exactly how to configure for, non TLS,
Non-production use, yeah. Yeah.
non-production use.
Playing
Yes.
around, hacking around.
Exactly.
This is awesome. This is so, I mean, I remember when the Catalyst proposal was approved, and it's been on my backlog just to do some reading and catch up because I kind of vaguely understood that it was a simple, elegant thing that needed to exist. But I needed somebody to hold my hand, and I really appreciate it. Thanks.
Oh yeah, no
This is
problem.
a
And
great way to
yeah,
start the week.
right. Yeah, so I mean, like I spent a most of well, a lot of the time on this part, right? Getting all of this stuff together. So now the Cardano node API side of the implementation should be really quick, and that's actually what I'm picking up this like now for the milestones.
Awesome.
And as I said, the Connect RPC actually supports both. So when you are the client and you're using Connect, you can tell it how to connect. So you can tell it with gRPC. Connect also has its own protocol, so you can use Connect as the protocol. You can use gRPC as a protocol, or it falls back to JSON, like a JSON RPC. So you can use all of them using the Connect library, and the client side gets to choose, and the server side just supports them, like just by magic. So it's very nice there. In that, like we don't have to worry about what the security requirements are, or like whatever kind of crazy firewalls people might have or anything like that. They get to choose, how they actually want to consume the data, and we don't have to explicitly write code to handle each of them independently, which is what you previously would have had to have done.
Exactly. Well, and so on that, when it comes to onboarding new devs, there's no reason to start anywhere else, right? We should be assuming that people will interact with this right away, right?
Yeah, I mean, I would, because it will simplify things greatly. Because the UTXO RPC stuff, especially using like Cardano Node API, it's just translating to all of the underlying Ouroboros
Right.
of the existing
Right.
Cardano node. In fact, Cardano Node API's basic reason for existence is to take the things that are only available from a Cardano node over that local Unix socket
Yeah. Yeah. Good.
and expose them over HTTP because, we have in internet time a billion years of evolution of securing HTTP, right? Like that's literally what everyone's been doing.
Right. Right.
So, when we're talking about a data provider, a backend service, a thing like that that you want to run your app on top of, right?
Mhm.
Knowing that, okay, we already know how to secure HTTP, right? Like you can use any of these billions of different ways of, putting proxies or whatever kind of stuff
Right. Right.
into, the mix and build it how you want. Whereas like, the security of the way Cardano node uses Ouroboros node client is, their security is you're running on the same machine. You own the node, right? It's your node. You trust that node implicitly because it's yours. And that's their security model. And there's absolutely nothing wrong with that, but that's not necessarily always
Not how
practical.
most people are going to build. Right. That,
Right, right. It's not developer friendly. It's
right.
extremely secure, from and very operator friendly, let's say, right? It's very like Unix guy friendly, but it's not front end dev friendly in any way.
Right. Right.
So yeah, and if you ever wanted to, you could actually explore both the spec itself and the code gen and see what it's actually doing.
Yeah.
You
And
know,
that's especially covering the HTTP part that you just shared. We Most people are never going to have a reason to go deeper than these endpoints. You're going to be able to build most of the outward facing applications. And then a tiny subset of people need to go deeper and like will play with Ouroboros directly. And this is the bridge to that, right? Like if you by looking at the code gen right here, you can go from an understanding of this kind of top level build level to kind of the underlying infrastructure level.
actually no. So
No. Okay.
the code gen is all of the interfaces and other things that you have to implement. And so for the client side, it's very, very well defined there. But for the server side, the part that hooks it up to Gore or to like Ouroboros in general is not auto generated. What is auto generated is the handlers for the HTTP side of it.
Okay.
Basically, the HTTP side is plugged in and it's like insert your code here.
So this reads this to generate. Is
The
that right?
other way around. No, so it's generated from the spec, and the Go SDK wraps the code gen. The reason why we have the sync
Okay.
here that we're pulling it in is to get the types. So there's
Okay.
in the code gen, there'll be two different for every one of the units, right? For like so for build or sync or anything like that. There's actually two packages. There's the sync connect package and the sync package. The sync package has all the types. The sync connect package is the one you actually use to connect. Yeah, so like if you look through and you just look at this and like look at sync, you'll see that there's also the sync connect sub package, right? And so this package is the actual connection package. And in fact, this defines both the server and client side if you go through and you look through all of these.
Uh,
But the other one, the sync.pb is the actual types and all of that. So this is where, like this is what a block ref looks like, right? So it has an index and a hash, and these are what they are. This is what it's shaped like, all of that sort of stuff. You can even see the JSON representation. So like when this stuff gets converted to JSON, it's already has the JSON
Uh,
annotations of what they're called. And
wow,
all of this, right, is completely auto-generated.
great.
So, this is great. You see there's all of these functions, and all of these functions are, use the same name. So as you go through here, like you'll see that there's like get tip, right? Like there's dump history request,
Right,
there's
right, right,
lock,
right.
right? So all of those functions that are in the documentation are in here. And this is what's
So
auto-generated.
you feed the Cardano, or sorry, the UTXO RPC schema to the CodeGen and you get this.
Yes.
And so
You
can
get
we look
that.
at the schema? Is the raw schema published here? Like what does that
Yeah,
look?
it's just under spec. So if you go to UTXO RPC, sorry, on GitHub.
Oh yeah, yeah, yeah. UTXO
Sorry,
RPC.
the UTXO RPC org.
Yeah, yeah.
Yeah, spec,
Spec.
right? Yep.
Okay.
So the way the spec is written, yeah, is there's it's versioned, and there's modules underneath of it, so we can go through and just look at each one. So like you can pick that, and you can go and look at sync again. All right. And then this is the proto buff. So this is the description of what the protocol looks like on the wire. Right. So you'll see here there's a message type of a block ref, right? And it has an index and a hash of uint64 in bytes, right? So you can see all of that stuff. And then, any chain block, we have one implementation. Right? We have raw, or we have a Cardano block, which
Yeah.
means we call it Cardano. So you'll see that all of these things, we have all of these field masks, like all of the stuff is defined in, like what gets sent over the wire. And that's what this is the definition of
And
is, this
okay.
is
Yes, yes, yes. And of course, this allows you to then generate compatible types in any language.
correct. So like if you look at the very bottom, you see the chain sync service that's defined here.
Right.
This chain sync service says we've created an RPC. It's called fetch block. It takes a fetch block request. It returns a fetch block response.
But now
And you
somebody
can
in
see
each
those things
language
right
has
above.
to, so this is a promise to now implement each of these.
Yes. And there are code generators already, for every language, right, that
Right.
take these
That makes sense.
proto buff files, these proto files, these definitions of what a protocol looks like,
Right.
and then generates them.
Right.
So if you
You
actually look
still
at
have to write all the logic, and
well,
obviously.
to hook it up in certain places, yes. On the client side, it's actually extremely easy, which is why you saw that wrapper.
Right, right, right.
If you look at the buff.gen.yaml down here, you will see this is the actual generator configuration. So we use this thing called buff.build buff to build it, and it's a wrapper around protobuf.
Mhm.
So Proto C is the protocol buffer compiler, and it's extremely convoluted and hard to write for. So these guys wrote a wrapper around it that makes it easier using these plugins. And so you can see the Go config, there's Node.js, there's Rust, there's Haskell, there's .NET. We also produce an open API package out of it. So, there's an open API spec that can be given out. And then it auto generates the documentation also.
Ooh,
Right.
okay.
Yeah, so it's pretty wild, and it generates, again, all the things, and then there's all the automation in here to write out all of those
It
various other.
generates all these docs.
Not this, but
Okay.
another set of docs that we need to hook up. It actually
Okay.
generates, and I'm not sure where they publish, but it does generate docs.
Cool.
Yeah.
Thank you. No, it feels really helpful to know just enough of what's going on under the hood.
Yeah, yeah, yeah. I
Just
mean,
to-
and again, the nice part is all of this is generated, like we
Right.
said,
Right.
so all of the promises, all of the how it looks, all of the shapes of everything, is consistent. And when we make a change, it'll be a change across all of the versions, all of the stuff, and it'll be, like a version compatibility thing. Like right now, we're early, so we might make breaking changes and things like that. But once we stabilize, V1 will always be V1. And so a provider providing V1, right, will always be providing the exact same API. And anytime we change it, the version changes of the API.
Right.
So have the compatibility of it, right?
Right. Right.
And yeah, I have a in progress branch that I'd been working on that I can actually show you for Cardano Node API if you want to go take a look at it real quick.
Yeah.
Let's see how much time we got. Yeah, we got time, like 10 minutes. So Blink Labs, yeah, Cardano Node API. It's in here somewhere. Yeah, there we go. And go to branches. Yep. So
Nice.
I was working on this, and yeah, go ahead and just click where it says one commit ahead.
This one.
Yep. And so this no longer applies cleanly because I've been making other changes, but this was where I was poking around with it. So we can scroll down past this a little bit, keep going. So, I added all the stuff. You skip that one, skip this to keep going, keep going. I'll tell you where to take a look at. Keep going.
Mm.
Right here. All right. So in the API, this is where I'm loading it. And, we can see that when we start it, there's a sync path. And so I'm hooking up the sync path up to the muxer that's serving. All right. And then so if you go down, you'll see where I implemented sync. And so this is the implementation. You see, again, I'm using Connect, the Connect RPC, right? So on the server side, we're using Connect also.
Mhm.
And then you can see, the sync and the sync connect. So if you go down and you look, here's fetch block. So I have an implementation of fetch block right here. So looking at the RPC side, we kind of took a look at it, and you can look here. You can see we're making it the fetch block takes a context, and then the request, which is a fetch block request, it returns the fetch block response or an error, right? Or an error. And you can see where we hook it up to Goroboros and Ouroboros. So if you scroll up just a little bit more,
Right.
you can see right here. All right, connect to the node. So under node get connection, we have a get connection function, which you could actually see if you scroll back up, but it doesn't matter. Point
Right.
is that's the magic that's using Goroboros. And so that's making our Goroboros connection. And you can see here we've deferred our disconnections. So our Ocon is our actual connection to Ouroboros.
Mhm.
The points here, the O common point, that's Ouroboros. So you'll see that what we do is we basically take the response from our block fetch, right? We get a block fetch response, and we're going to take that and map it into, all of the response parts, right? So if you look at it, if it's greater than 0, then for each block ref that has been requested, right, we're building what we're going to respond, right? So we're going to get the index, we're going to, right, get the hash from all these various things.
And this is basically where you're following the rules of the spec.
Yes, yes. And that's where I'm defining what it looks like. Or in the case of if you didn't provide one, this is if you provided one. So this is all pre-configuring. Otherwise, we're just going to get the current tip.
Right, 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 right,
All right. So I get the current tip, but the point is this is what we're going to fetch. So
right.
this is the block that we're going to fetch is, so if you
Get it
didn't
out of the way.
specify one, we're just going to grab the current tip.
Right.
And then you can see where we actually do the thing. So block, we get the block, right, from Ocon,
Yeah.
Ouroboros.
Yeah.
So we actually talk to the node at that point. We get the block. It gives us this block that we've defined, right? The point. So it
Yeah.
gives us a single block. And then below that is where we start to create our block to respond. So this is now sync. So that's UTXO RPC sync module, right? Any chain block type is Cardano. And then I wrote this helper, and all of these helpers we don't need anymore. Like I added a bunch of stuff into Goroboros directly, which is why some of this doesn't apply. This new block from block is a little confusing, but it means take an Ouroboros block and return a UTXO RPC block. And so I'm taking the block that I got from Ouroboros above, right? I'm taking a UTXO RPC block, I'm assigning it to Cardano, assigning that to the chain, and then assigning it to the block response by appending the block type to the response that we're going to send, which is our fetch block response, and then we return it. Right. So anyway, yeah, this is the implementation. This is all of the glue of, how do we take the request and turn it into a response, on the RPC side. And, so anyway, I'm starting.
Thanks. Brilliant. Yeah, no, this is great.
Yeah,
It's
yeah.
great.
So, but again,
Awesome.
you see, the things that I'm implementing are the same, fetch block, dump history, right?
Right.
Follow tip.
Right. And even these are already building on top of the massive work of having Goroboros in the first place. Like
Absolutely.
you could just start in some other language and go from scratch, but it certainly
Yeah.
have this.
Yeah, having Ouroboros definitely solves a lot of it. And that's also because we're writing, the server side, right? The again, not everyone needs to write the server side unless they want to. And we want to because we wrote Ouroboros, right? So we want to build from the ground up entirely, the entire Go side, so that we're not relying on a Cardano node anywhere at some point. But for now, our goal is to, build it so that it is Go from node up, essentially. Yeah,
Thank you. And thanks for building this once, because now somebody like me, our team can start playing around from this perspective and consuming all this stuff, making sure that it's used for something. So thank you. Brilliant. Well, my homework is to just run with some inspiration and brainstorm some things we might do with each of these. And I hope that if anybody else is interested in doing the same, that you will. If there's an idea you want to implement, something you think will knock people's socks off in terms of saying, I didn't know it was that easy to do that. That's what we're looking for here, are just little examples. And I think we can plan on having a toy or two to play with next week. So let's see how that goes.
yeah. The one thing that I was definitely talking about is the right part in Andamio CLI is for
Yeah,
sure a
yeah,
area of diversification, an area that's cool because the gRPC is really about the getting the stuff to build the transaction, but it still
yeah,
doesn't build the
yeah.
transaction for you, right? Like it leaves that to a higher level application to, consume the data and actually design and shape the transaction itself before you send it back to the wire. So it's I definitely would like to see cool areas over there, more on the right side where, like how do you create a NFT? How do you create a whatever, right?
Right.
From all of those sort of things and getting to the end point of now I have a transaction that is ready to be submitted,
Correct.
right? I've queried the things, I've done the stuff, I've appended it, so really Cardano CLI analog.
All right. So next week, let's try to fire, yeah, just a simple mint a token transaction first, and then let's see if we can hook an NFT image up to it.
That would be cool.
That'd be fun. Thanks, Chris, for that tour. And thanks for everybody who hung out today. This is I'm excited we're doing this on Mondays. I hope this works for everybody. But feels good to carry some inspiration into the day. So I appreciate it. All right, well, I think we have a really cool screenshot to share on this week's blog post and some fun ideas to start pointing people to. And I'm excited for next week. Let's see how close we can get to doing something like this. I'm going to hack around this week and see what I can come up with. And of course, I'll be in touch with questions when they come up.
Sounds good.
All right. Have a good week, everybody. Thanks for hanging out today. And if you're checking out this video later, we do this on Mondays at 1300 UTC. Check it out, gimballabs.com/calendar, and drop by for some Go live coding. See you soon, everybody.